Good afternoon everyone. My name is Katie Wilkie and I'm here today to talk about what the language of musicians can tell us about interaction design. I'm not standing in front of the slides, am I? Okay, so music, as we all know, is a very complex domain. It involves numerous concepts and abstractions, and as musicians we're quite regularly dealing with numbers of concepts such as modulation, counterpoint, voice leading, and we work with lots of different notations like staff notations, guitar tablature and figured bass. Unfortunately, what this means is that interaction design for music and complex musical concepts can be quite challenging. The reason for this is that even the most skillful musicians among us and the most experienced of us may have problems communicating these concepts, these abstract concepts, in terms that a less knowledgeable user or designer is unlikely to understand. So, as an example, how many of us here could quite clearly explain voice leading, counterpoint, atonality or Schenkerian analysis to someone who's a beginner musician or an amateur? So these difficulties in communicating key domain concepts can be compounded because concepts such as rhythm, pitch and chords may not always readily map to elements of an interaction design or user interface controls themselves. So a potential solution that I've looked at to the problem of designing interactions for domains such as music is based on the theory that our understanding of abstract concepts can be grounded in our prior sensory motor experiences of things like space, temperature, height and force. So these experiences are called image schemas, and there are a number of different image schemas that have been identified based on sensory motor experiences such as containment, which is based on holding something in your hand, for example. Up-down, which is based on your experience of height, mountains, that sort of thing. Paths, based on movement from one object to another, similar to what Jamie was talking about earlier. And also momentum, or in this case, my cat there sleeping, not momentum. So these image schemas, which are often identified through spoken or written text. So for example, if you look at the example there, take the cake out of the oven. The word out suggests the presence of the container image schema. Now the great thing about image schemas is that they're really powerful and that they can be used to carry out spatial reasoning operations. So if you think about an object A, which is in container X, and container X is then in container Y, then A is going to be in both X and Y. So that's very powerful ways that we can use image schemas. So the great thing about image schemas is that they don't also just apply to tangible concepts such as the cake in the oven, but we can also actually apply them to abstract concepts such as melody. And when we apply an image schema, an example of a prior sensory motor experience, to a concept such as melody, that's called a conceptual metaphor. So for example, in the example there of the text, the melody starts in C major and modulates to G. The words start and to suggest a path image schema. If we then apply that to the concept of melody, you can see in the little notation there, that creates the conceptual metaphor. Melody is movement along a path. So there have been a number of different applications of image schema and conceptual metaphor theories to various different domains in an attempt to understand how those domains are structured. So a couple of quick examples for you are Lakoff and Nunes, who applied image schemas and conceptual metaphor theories to arithmetic and maths, and Lakoff and Johnson applied the same theories to philosophy and philosophical thought. But the three main applications that are of interest to me and us as musicians are the application to music theory and phenomena, and also to user interface and interaction design. Now, unfortunately, although there are applications to music theory and user-facing interaction design, most of those applications are based on very simple concepts. and the applications to interaction design in particular are generally restricted to simple concepts rather than abstract concepts such as harmony, which is what I've been looking at. So we designed a study to explore the potential for these conceptual metaphors to inform the analysis of music interaction designs. So I'm going to quickly chat to you now about the study and what we found, some of the results from the study, and then I'm just going to finish off the presentation by just chatting about some of the implications going forward for music interaction design that you can maybe take forward into your own designs. So when we designed the study, we recruited 3 very skilled and experienced musicians. We gave them an excerpt of a musical score of a sacred motet by Monteverdi and asked them to work together to discuss the melodic and harmonic progressions in the excerpt, as well as their own emotional responses to the excerpt. So we recorded their conversation and we transcribed it, and then we analysed that transcription looking for keywords, for example, things like from and to, or in and out, inside, outside, that type of thing. And we used that information to identify the conceptual metaphors that the musicians were using when they were talking about the excerpt. We then used those conceptual metaphors to evaluate 2 existing interaction designs. So the transcription of the audio recording was analysed, as I said, to identify the conceptual metaphors. And I've given you a few examples of some of the conceptual metaphors we identified there. So one of the common ones, an example phrase was, "You've gone from A major to E major." So that was an example of harmonic progression is movement along a path. And another key one in music, conceptual metaphor, a chord or a key is a container for notes. So an example of that was the musicians saying, "I'm in G major," when they were talking about a particular part of that excerpt. So once we'd identified all the conceptual metaphors, we then looked to evaluate 2 existing music interaction designs. So those were an application called Harmony Space, which is based on the Bolzano and Longut-Higgins theory of harmonic perception, and it exploits various spatial metaphors to help beginners understand the principles of tonal harmony and harmonic progression. And we also looked at GarageBand, which I'm sure most of you know is an application that's available with the Mac OS X operating system, and it's similar to other digital audio workstations like Logic or Pro Tools. So I'll give you a screenshot there of Harmony Space. Now, Harmony Space displays 12 notes of the chromatic scale. They're in a 2-dimensional grid, and depending on the current key context that you're in, the notes in the current key context will be highlighted in white, and the notes that are not in the current key context will be highlighted in black. So in this example here, we're in G major, so I'm not sure how well you can see the screen, but all of the notes in G major, G, A, B, C, D, E, F sharp and G, are highlighted in white, and all the other notes of the chromatic scale are highlighted in black. Now, when you move key context, so for example, if I modulate from G into C, then the white notes are then going to be the notes that are in the C major scale, C, D, E, F, G, A, B, and C. So by moving around and modulating, you can actually see the key window moving across the grids there, which emphasises the movement of the metaphor of movement through harmony. Also, other interesting things about Harmony Space is that in a basic configuration, if you select the note G there, that's going to play a 3-note triad based on the key context that you're in. So in this context of G major, if I click on G, it's going to play the notes G, B, and D. So we took the conceptual metaphors that we'd identified from the transcription, and we used them to assess harmony space and evaluate it to decide how well the interface supported or contradicted the conceptual metaphors that we'd identified. So parts of the design that we actually looked at were the layout, the configuration, and the behaviour of the controls. And what we found is that support for many of the conceptual metaphors associated with harmony was good, which is as expected because it's supposed to help people understand harmony. However, support for conceptual metaphors associated with other musical concepts was not strong. So, just give you a brief rundown here of some of the results. This is some of the examples here. So if we look at harmonic progression as movement along the path, because the key window moves as the user changes the key context, that reinforces this particular conceptual metaphor. And there's also a function which allows you to trace the movement of the root chord, of the root note, through the harmonic progression as well. Other interesting results that we got as well. Harmony space does not support the concept of a musical rest. It's purely for harmony, so it doesn't support musical rest or silence. So it did not support the conceptual metaphor musical silence as a blockage to movement. Interestingly, harmony space provided partial support for the conceptual metaphor, which is very common in Western music, high pitches up, low pitches down. It was supported in bits of the display, but not in the main grid area. So just quickly looking at GarageBand, I'm sure most of you have seen screenshots of GarageBand before, so it's very similar to other software like Logic or Pro Tools. You've got audio and MIDI tracks that you can mix together, various other displays such as the piano roll and effects and so on. So similar to harmony space, we also used the conceptual metaphors that we identified to evaluate GarageBand. And similar to harmony space, we found that GarageBand did support some of the conceptual metaphors that we'd identified, although it was a very different mix of conceptual metaphors. And in particular, we found one example where one conceptual metaphor was actually contradicted by certain aspects of the design. So again, you can see an extract from the results there. So contrasting with harmony space, harmonic progression is movement along the path. That wasn't supported at all by GarageBand, but again, that's expected because it's not really designed to help you understand harmony. It better supported high pitches up, low pitches down, because you could see from the vertical placement of the MIDI note blocks roughly what the pitch would be. But interestingly, if we look at musical silence as a blockage to movement, if you don't have any MIDI blocks displaying on the screen, that suggests that there's nothing happening in that part, there's silence. But similar to all the other digital audio workstations, GarageBand actually continues to scroll the tracks during playback, so actually that contradicts the conceptual metaphor. So just to summarise then, the evaluations that we carried out didn't really reveal any particular obvious flaws, but it did give us some good insights. So firstly, we were able to identify trade-offs in the design where support for one task was enhanced at the expense of another. And we also identified opportunities to provide support for some conceptual metaphors. An example of that was in harmony space. The chord trace functionality was actually added to support and reinforce the conceptual metaphor harmonic progressions movement along the path after we did an earlier trial evaluation. Now, one of the key things for us as interaction designers is how can we use this information going forward. So the conceptual metaphors that are used in the domain can influence many aspects of an interaction design. So for example, we often talk of movement from one note or chord to another, which could suggest that in some circumstances, gestural movement-based interactions might be more appropriate than a standard Windows icon mouse pointer design. User interface controls themselves can be used to reinforce conceptual metaphors. So for example, a vertically organised slider control might be more appropriate than a dial control for pitch, because that reinforces the conceptual metaphor high pitches up, low pitches down. And also as well, when we look at layout and configuration, near-far is very important in harmony. So we may want to organise labels that are used to define chords or notes closer to each other or further away, depending on the context that we're in. And we also might want to think about the terminology, so the menus, help information, labelling, all that sort of thing that we use in a user interface, because some of that can also expose the conceptual metaphors, and I'm just very quickly, to finish up, going to give you a very quick, for instance, I promise it's quick. One of the great things that you can use conceptual metaphors for is to identify areas where the design is contradicting a standard conceptual metaphor. So, for instance, after many years of playing early music, last year I decided, after finishing my thesis, I wanted to take up blues bass guitar. And I find that quite challenging. But one of the things I find very challenging about it is the order of the strings. So one of the most common conceptual metaphors in Western music is high pitches up, low pitches down, which you can see if you look at staff notation. The higher the staff line, the higher the pitch. But the strings are upside down based on that. So just a very quick example of how a simple interaction design can contradict a very common conceptual metaphor and cause confusion.
Yeah, thank you. We have a few minutes for questions if you want. Yeah.
Yeah, I thought that was really interesting. I just wonder if you've done any work on or are aware of work on conceptual metaphors in relation to sound as distinct from music.
Yes, so there is some research by Alyssa Mantle and her colleagues. So they've done excuse me, a number of research projects based on, can't remember the name of the application now, but it's all about sound parameters and embodied movement. So for example, moving faster or slower to define a particular sound parameter. So there is some, certainly some crossover there, but again she's looking at very straightforward embodied metaphors and sound parameters. The particular research area I'm looking at is the more complex aspects of music, such as harmony and pitch and so on.
I've got a little one.
Yeah,
How do you distinguish between, in terms of lack of to answer, how do you distinguish between metaphor and conceptual metaphor? What is, why are you making that?
So in conceptual metaphors, they usually break that down into three separate types. So you have your primary metaphor, which is things like more is up, less is down, which is very much based on your prior sensory motor experiences. You then get the more complex metaphors, where you start to apply that to abstract domains. And then the third level is what they would call novel metaphor, which is more like the literary metaphors that we would use. So maybe associating someone's eyes with sparkling diamonds, or their voice with a lion, and so on. So the way that we distinguish those is really just looking very closely at the dialogue, and actually looking for those keywords, things like to and from, and associating that with the image schema, rather than looking at the more literal image-like description of, you know, a piece of music is perhaps like the sea, or you know, birds flying overhead, or children playing, that type of thing.
So you made a kind of catalogue of these?
We do. There's quite a few. I don't know if I can go back. Yep, and my references there. There are a few examples there that other researchers have documented. In my thesis, I've got a big list as well of the ones that I've identified during my research. But yeah, there's a lot out there, and music is so complex. There's plenty of opportunities for many different metaphors to appear.
Yeah, I think it's time for lunch.
Okay.
Thank you.